Welcome to the next session on ANSYS Workbench tutorials. In this session, we will analyze a 5-digit NACA airfoil, that is 35012 NACA airfoil, for its static structure analysis. We will start by double-clicking on static structural. I'll first go to engineering data and double-click. I'll go to engineering data sources. Here I'll choose general materials. I'll go to aluminum alloy and bookmark it. I'll go to project and update project. Next I'll go to geometry and right click. I will directly import the geometry which I have created before. I'll go to geometry and double click. The airfoil is of 2D form, so I'll go to extrude. I'll select the surface body from here, apply. It is asking for the direction vector, so that is the XY plane. Apply. I'll give the depth as 500 mm and generate. If you click on look at, you'll be able to see this entire airfoil. I'll go to line body and right click, suppress body. I'll go to surface body and suppress it. Then I'll close this geometry. I'll go to model and double click. I'll go to geometry solid. I'll change this material to aluminum alloy. Then I'll go to mesh and I'll give the sizing as 0.01 meter. You can give it to a more smaller value, but my software would not support because I'm using a student version. Then I'll go to static structural, right click, insert, fix support. I'll fix this end, apply. Now there are various static structure analysis possible which we have already discussed. So I'm just using one of them. So I'll just click here, right click, insert, rotational velocity. I'll change vector to components. Say along the Z axis, I'll give the RPM as 2000 RPM. Then I go to solution and right click, insert, deformation total. I also want to see the deformation along the y-axis, so I'll select directional. Orientation is y-axis. I'll go to solution, right click, strain equivalent, right click, stress equivalent. I also want to see the fatigue, so I'll select fatigue tool. Here I'll choose the mean stress theory as Goodman theory. I'll again right click on the fatigue tool and insert life. I want to see the damage, safety factor. Then I'll go to solution and solve. So now we'll go to first total deformation. I'll go to contours and select smooth contours, edges, no wireframes. So you can see here. Then I'll go to animation. So you can see here the deformation is least at this end and it is the maximum at the other end. I want to see the readings in mm. So here the deformation is 5.8 mm. As you can see, minimum is 0. Then we'll go for directional deformation. I can see along the y-axis it is 5.68 mm maximum. This also you can animate, it will be the same as the total deformation. Then I'll go to equivalent elastic strain. You can see the maximum strain is 0.0013724, which is at the tail end over here, and the minimum is 1.91 into 10 raised to minus 8, which is over this zone. Then I'll go to equivalent stress. The value is 97.43 8 megapascal, which again you can see is over here, which is the stressed zone. And over the rest of the area, there is a variation of stress. You can go to this probe and you can select max min. So you can see maximum value is here, minimum is here. If you move your probe over this aerofoil, you will get these values at any position that you want. So if you remove probe and only select max min, you will see the max min. If you also happen to select probe, you're getting extra values at any point over here. Or if you alternately don't choose max min and you only choose probe, then you can get the value at any desired point of your choice. So you can click wherever you want and you can get the values. And if you don't want to see these values, just right click over here, delete all. So all will disappear. You can click on probe and unselect it. So this is how you get the values. Once this is done, I'll go to fatigue tool. I want to see the life. The maximum life is 1 into 10 raised to 8, as you can see here. And in this red color, you can see it is 2.26 into 10 raised to 7. Now, please be careful that this value is higher as compared to the red one. So that's the life. Again, if you want to see the max min, you can click on max min and you'll get the values. Then I'll go to damage. You can see here it is 44.142 as the value suggests, highest value. Lowest is 10. I'll go to safety factor. Now this is quite interesting because you can see that the aerofoil is safe in quite a zone where it is blue, where the value is 15. It is 0 in some cases and it is lying between 0 and 0.8 at some places, which is shown in red color. And then again in orange color, the zone is from 0.84 to 5. As you can see here, if you choose probe, you'll get these values. See, it is between 0.8 and 5. And then again, it is between 5 to 10 in this green color zone. As you can see, you can run the probe over it. And in this blue zone, as you can see, if you move your probe, it is 15 or 14 point something, 13 point something. So it is 14.993 as you can see. So it is close to 15. So that's how you should be reading these values. Do not assume that red always means more and blue always means less. It is not the case. That's what I have proved you here. Blue in certain cases means more. Red means less. In fact, it indicates danger over here. Or rather, I would say it is indicating a low value which could lead to failure. So that's how you're going to analyze this aerofoil for its structure analysis. With this, I end the session. I hope you have understood the analysis. If you have any doubts, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.